In this video, I'll show you how to prove trigonometric identities using double angle identities. This is question 1 in the series. The question asks, prove the identity shown below, where the left side is equal to 0. To do this question, we need to refer to at least 3 different known identities. The first one being cosine of twice an angle, which is cosine of 2 times an angle is equal to cosine squared alpha minus sine squared alpha. So I'll replace this part with the following, where I have cosine squared alpha minus sine squared alpha plus this part, which hasn't changed yet. Furthermore, we will change this part of the expression using the difference of 2 angles for sine, which tells us that if we have minus in between the 2 angles, we will convert this expression to one that looks like this with minus in between those 2 terms. So let's rewrite everything with that in mind. We have cosine squared alpha minus sine squared alpha. That part hasn't changed yet. Plus sine alpha cosine beta minus cosine alpha sine beta. And that's equal to 0. Now we've been told that alpha and beta are the 2 acute angles of a right triangle. So just to picture this, we have, let's say, a right triangle or a 90-degree angle. And this, let's say that this angle right here, alpha and beta, are complementary. So if you add alpha and beta together, you'll end up with 90. That being said, we can use complementary angles identity, known as cofunctions, to change cosine b into sine alpha. So this part can become sine alpha. We can also switch this sine beta into, according to this, cosine alpha. So I'm going to rewrite this expression with that in mind. Notice now we have sine alpha times sine alpha. That becomes sine squared alpha. And we have cosine alpha times cosine alpha. That also becomes cosine squared alpha. Where we end up with cosine squared alpha, that part hasn't changed, minus sine squared alpha. This we determined to become positive sine squared alpha, and this we determined to become minus cosine squared alpha is equal to 0. Now look, minus cosine squared alpha and positive cosine squared alpha cancel out, and these 2 terms also cancel out, leaving us with 0 on the left side and 0 on the right side. And there you have it. We just proved the following identity, and that is how to prove trigonometric identities using double angles. Make sure that you watch question 2 for another example.